Let's try now to understand what is the connection between electric field and potential energy. That we'll now call electrical potential energy because we're talking about charges. The picture here is a similar example as before. We have two charges, Q1 and Q2. For Q1, I show the electric field, which is emitted radially by the charge. The electric field is indicated with E. There is a little arrow here just to indicate that in any point of the space, it's not enough to tell the value of the electric field, but you also have to indicate what is the direction of the electric field. And then we have Q2 here, which will fill the electric field. The intensity of the electric field that Q2 will fill depends on the distance r. The higher is the distance r, the lower is the intensity of the electric field. Q2 will be subject to a certain force F, which depends on the value of the electric field where Q2 sits, multiplied by Q2. The force F applied to Q2 will push Q2 away and will do a work on Q2. Because again, there is a movement and a force in the same direction of the movement. So because there is the possibility of a work to be done that arises from the relative position of Q2 and Q1, we can say that Q2 has a certain potential energy. To summarize, a charge in an electric field has electric potential energy because work can be accomplished by the field via Coulomb forces. Similarly to the example before, where the ball had lower energy when it was on the ground, in this case, Q2 will have lower energy if it's very, very, very far away from Q1, because the intensity of the electric field is very small. Some work can be done, but it's a very small work. Whereas if the two charges are very close to each other, they have a lot of potential energy because the work that can be done is greater. It is possible to demonstrate that the potential energy of the charge Q2 can be written with this equation. So U is equal to K, which is a constant, multiplied by Q1, Q2. So it depends on the value of Q1, obviously, because the higher is Q1, the bigger is the electric field. It depends on Q2 because the bigger is Q2, the bigger will be the force. So the bigger will be the work that will be done. And it also depends on R, on the distance, because the smaller is the distance, for the same value of the charges, the higher will be the electric field in the position of Q2.